So we first need to find f evaluated at 0. So we'll have sine of 0 squared, which is just going to give us 0. And the other little piece of this is we need to find our derivative evaluated at the center. Now, do keep in mind that the function that we have here, f of x, is equal to sine squared x. Because that little exponent is in between the trig function and its argument, that is the same as sine of x quantity squared. So when we write that with parentheses, we're seeing that because it's parentheses to a power, that is our general power rule, that specific case of the chain rule. So when I take this derivative for f prime of x, I will have 2 times sine of x, and then the derivative of the inside will just be cosine x. Now, for the linearization, we need to evaluate this at the center of the linearization. So we plug in 0. Now, sine of 0 is just 0, so this will evaluate to 0, because you have 0 times 1 times 2. All right, so this is going to be kind of a peculiar looking linearization. You plug into the formula L of x is equal to f of a plus f prime of a times x minus a. So our center here is 0, so that's going to be our a value. And then we plug in those quantities. So f of 0 we found to be 0, f prime of 0 we found to be 0, and then x minus 0. So what we're getting for our linearization is just that L of x is equal to 0. Okay, so this part here is if you memorize the formula, you would just plug in the a's and then plug in their quantities. The other thing that you could do, and I just want to keep referencing this, is you could go through the tangent line approximation and then solve for y from the tangent line. So if you did that, you would have y minus the y1 coordinate, which is 0. The derivative evaluated at that 0 center would also give you 0, times x minus the x coordinate of 0. And then you would see you just have y is equal to 0, moving the 0 over. And the thing to remember is that if you do go through the tangent line solving for y, you do not want to write the final answer as y is equal to 0. You're talking about a linearization, so you have to communicate that, and you have to say that y is equal to L of x. So you do need to make that last step and actually refer to the y variable as your L of x equals 0.